So let's use our new arc length formula. It says find the length of the curve over the given interval. So my r equals 1 minus sine theta, and this is going to be from 0 to 2 pi. So if you guys remember the formula, so there's our formula. So now we're going to need our f of theta here, and remember f of theta, since f of theta equals r, our f of theta is 1 minus sine of theta. So don't forget that. It's like when we have y equals some function of x, we can call it f of x too. So for r, we can call it f of theta. So there's that. And we need the derivative of this. So the derivative of f of theta is actually going to be negative cosine of theta. So now all we're going to do is just sub all that in our handy dandy formula. So we have our L equals the integral, and they give us the bound for this. I think sometimes when we're dealing with these, the worst thing to come up with is the bound, as you've seen in the previous problem with the two interiors of the regions. But here we're going to deal with this square root here, and most of the time we deal with these, we're not going to do these by hand. Most of the time we're just going to plug it in our calculator, because the square roots really throw things off when you try to get perfect squares and stuff. It's really difficult to do all that. So it's better to just say, hey, let me plug it in my calculator. So now I'm going to need f prime of theta squared. So I'm just going to plug that in here. So this is going to be negative cosine of theta, and that's squared, plus, and then we have the other one, which is 1 minus sine of theta, and that's squared, and that's square rooted here, and d theta. So now, again, you will have to simplify some of these. Sometimes if you don't simplify them, you keep in that form, they actually won't integrate it. It's weird how the calculator is sometimes. Sometimes it wants it simplified more. So just kind of keep that in mind too. If you don't get an answer. Okay, so I'm going to square those. So when I square it, it's going to be integral from 0 to 2 pi. And the integral of this first part is going to be cosine squared theta plus, and this is going to be 1, and that's going to be minus 2 sine theta when I multiply it out when I square it. And that's going to be plus sine squared theta. And that's going to be d theta. Now, if you notice, this simplifies quite a bit here, because that sine squared theta and cosine squared theta, when I add those together, because there's a plus for both of those, or positive, that's going to give me 1. So this integral from 0 to 2 pi is actually 1 plus 1 minus 2 sine theta d theta. And I just kind of want to show you that together gets me a 1 here. And then I still have this 1 here, which is this one here. So just kind of keep that in mind there. Okay, so now what I'm going to do is I'm just going to put those together. So this equals the integral from 0 to 2 pi of square root of 2 minus 2 sine theta d theta. So then our answer equals 8. Nice, interesting answer there. So that's the end of this. Now again, when it comes down to using this formula for the arc length, it's just plug and chug. Nothing more than that. So that's what's nice about this. Just plug it in. And I think the biggest thing to realize, though, is r is equal to f theta. And once you understand that, you can find f prime of theta and no issues. Other than you'll probably only be able to get it down so far. And sometimes you'll have to get it down to there to integrate. It doesn't always integrate. Like if I just plug this in, it may or may not work. So that's the interesting thing about the arc length formula in polar. Sometimes you got to simplify your integral before you can integrate it on your calculator. All right, that's it.